We are supposed to write down a differential equation for theta and t. So we are supposed to come up with a d theta, dt. And according to the question, theta is the temperature of the water, t is in minutes. So for d theta dt, we are working on the rate of change of the temperature of the water. Let's try to read the question and see whether there's any rate of input into this system and what is the rate of output from the system. According to this question, there is nothing that's going to cause the rate of change, rate of temperature of the water to increase. So rate of increase is 0. And according to the question again, the temperature decrease at a rate that is proportional. So proportional to the difference between the temperature of the water, so theta, and the temperature of the room, which is given to us as 16. So this minus 16. So d theta dt is going to be defined by rate of input, which is 0, minus away rate of output, which is k theta minus 16. And because we define the rate of output as negative ourselves, so this k here, we will let it be a positive constant that we introduce into the system. So this is going to be minus k of theta minus 16. Let's try to solve this differential equation so that we can find theta in terms of t. So that we can find theta in terms of t. So this, I'm going to divide across to the other side. We will have a 1 over theta minus 16. And d theta dt, this is equal to minus k. Integrating both left and right hand side with respect to t, so on the left hand side it will become 1 over theta minus 16 d theta. On the right hand side, minus k integration of 1 dt. This is going to be ln of modulus of theta minus 16. As for this is going to be minus kt plus an arbitrary constant. Let's go for a. So modulus of theta minus 16, this is going to be e to the power of minus kt plus a, which I can definitely rewrite it as e to the power of a, e to the power of minus kt. Removing the modulus from the left hand side, theta minus 16, this will be plus or minus e to the power of a, e to the power of minus kt. And let's just try to rewrite this as b, e to the power of minus kt, which means that b is a representation of plus minus e to the power of a, which means that theta is going to be equal to 16 plus b e to the power of minus kt. Let's see whether there's any way for us to solve for b and to solve for k. According to the question, the temperature is going to fall from the 80 degrees Celsius to 32 degrees Celsius after 30 minutes. So making use of this piece of information, when t is equal to 0, we are looking at theta to be 80 degrees Celsius. So subbing into here, we are talking about 16 plus b e to the power of 0, which is 1. So this is equal to 80. So we'll be able to get a value for b. B is equal to 64. And after 30 minutes, so that is when t is equal to 30, the temperature of the water falls to 32 degrees Celsius. So this is going to be equal to 32. So we are looking at 16 plus b is 64. So 64 e to the power of minus kt. T is 30. So minus 30k. This is equal to 32. So e to the power of minus 30k. This is going to be equal to 4 to the power of minus 1. 1 over 4. 4 to the power of minus 1. And the reason why I'm writing it this way, right, is because minus 30 e to the power of minus 30k. If you look at what we have here, in fact, we can rewrite this as e to the power of minus k, then to the power of t. So, rather than finding the value for k, we can actually find a corresponding value for e to the power of minus k, which actually exists here because this is just e to the power of minus k, then to the power of 30, which is this 4 to the power of minus 1, which means that e to the power of minus k, it can be 4 to the power of minus 1 over 30. So now if I were to sub this and this back into here, we have theta to be equal to 16 plus b is 64, e to the power of minus k is 4 to the power of minus 1 over 30. Then this to the power of t. So theta is going to be 16 plus 64. Then we have here as 4 to the power of minus t over 30.